Hi, I'm William from SSW TV, and we're joined here today with Tom Harvey from HashiCorp. And this is an Ask Me Anything session, so the crowd can ask Tom anything they like about Terraform, and then I've got a few questions of my own. And so welcome, Tom.
Hey, thanks for having me.
Yes, we just had an awesome user group session. We were sort of taking everyone through the nice bits of Terraform and what you can do with it. So just now for a crowd, I'd like to sort of ask you in a nutshell, can you explain what Terraform is and what can it do for us?
So Terraform provides a common language to be able to provision just about anything across any platform. So Terraform works with multiple providers, and they cover things like cloud, so AWS, Azure, Google, etc., to like SaaS services like GitHub, PagerDuty, etc. And you can chain all these providers together. So you can create your, let's say you create an app service in Azure, and then thread that through with your Azure monitor to PagerDuty to say, hey, when this alert fires, notify me via PagerDuty. And all this infrastructure is in code, all your infrastructure is in code, which means you can do things like plan and work out what's going to happen.
If we were to adopt Terraform, how would we convince the business? What benefits would Terraform sort of bring to us?
So the first one I covered just a second ago, the plan, allows you to see exactly what changes Terraform is going to make to your infrastructure, which means that you can be confident in the changes that are going to happen. So for instance, if Terraform knows that when you change a SKU from basic to standard, or standard to premium, or whatever change you're doing, if it knows that's not possible, Terraform will prompt you and say, hey, I need to drop this database. Is that okay? And dropping a production database may not be a great idea. So you can choose what happens there.
Cool. So in terms of the changes that Terraform detects, it'll do the minimum changes. It won't go and try and redeploy and do sort of the create or update version of templates.
So Terraform knows what changes can be applied and what can't. So for instance, if you try and change a SKU via like an ARM template or via the CLI or whatever, those mechanisms will stop you and mid-deployment and say, hey, you can't do that. You need to like destroy it and recreate it. Terraform knows what these changes are. And so for instance, we'll tell you in the plan, hey, I need to drop this database. Is that okay? Or if it doesn't need to make those changes, here's the change. I'm going from value A to value B. Here's the change I'm going to make.
So compared to ARM templates in Azure, what's the main contrast between Terraform and ARM templates? How do they differ?
So ARM templates are JSON. Terraform uses its own configuration language called HCL, which is the HashiCorp configuration language. It's kind of JSON-like, kinda. But it allows you to create reusable code. So similar to an ARM template, you have resources. Sorry, excuse me. Similar to an ARM template, you have resources. So rather than define them in JSON, you define them as individual blocks. So for instance, a resource group and then a virtual network or whatever you're doing. And they can have dependencies between one another in a very similar manner to like how ARM templates do. But rather than just interpolating the ID of the resource group or the name or whatever it is, you're able to do that with any property. And Terraform can manage just about any resource within Azure, so it can work cross-resource group too. So if you want to spin up 3, you could do that. You can also connect to multiple subscriptions from the same Terraform file if you want to be able to create like a virtual network gateway across 2 subscriptions and then automatically create the pairing.
When would you, in your opinion, say it's better to use Terraform, or when is it better to use ARM templates? Sort of, are they better in different situations?
Terraform, we code. So technically, Terraform was built against Azure SDK, which speaks to the APIs on the back end. An ARM template, by comparison, you submit the JSON file, the ARM template, to the API, and it does whatever it does behind the scenes. By nature of us using the SDK, not everything is necessarily available in Terraform. We're doing pretty well. All the major use cases there now. There are benefits to using each. What's quite nice with Terraform is you're able to use an ARM template from within Terraform. So for instance, you can provision your In the case of a network, you could create the subnet with Terraform, then go to something that Terraform doesn't support, like a, let's go the service fabric cluster, which it does, but anyway. You could thread the subnet ID through to the ARM template from within Terraform, and then get whatever value you wanted out of that, like the IP address or something, and take the output of the ARM template and thread that back into Terraform, which means that you can get all of this in one unified script.
Okay, cool. So does that still maintain that state? So next time you want to deploy with small change, will it actually pick up that service mesh or service fabric that you just deployed?
So Terraform can't diff changes with an ARM template because we don't have access to all the properties. But Terraform will go, hey, this ARM template has been deployed. And so we can get the variables from those ARM templates. We can't diff the properties in it. But yeah, it works the same way as any other part of Terraform aside from that.
All right, so just sort of to change course a little bit, can you tell us how did you end up starting to work as an engineer at HashiCorp? So
yeah, I started contributing to the Azure provider 2.5 years ago now, I guess. Eventually, so we were using Azure at my last place. We had ARM templates. They were great to a point, but we found we had a lot of ARM templates and a lot of code we weren't reusing. This was before linked deployments in ARM templates. So yeah, we started looking towards Terraform for this. We started moving some stuff towards it. So like our build agents and stuff, our monitoring tooling, we started moving towards Terraform. We started building these modules for, hey, here's a set of VMs we needed to create, here's a network, here's whatever it was, and creating reusable components from that. So yeah, basically I started out contributing to Terraform going, hey, we need this thing that doesn't exist, whatever it is, Redis I think it was. And so we contribute the Redis resource, and then spiraled from there. So
Terraform's open source, right? So yeah.
Right, yeah. So Terraform's open source, it's all ready and go. But yeah, I started off contributing through that, and then eventually ended up joining, 6-9 months later.
So how would it feel? You've contributed to the code base, you started a new job, or you already know everything. How is that different to starting a different job? How did that feel? It's
quite weird going in and knowing the code base pretty well on day one, going in and not having to read through how much history to go, hey, I know how this works, let's just get on with stuff.
That's exciting.
It's quite nice.
What advice would you give anyone else who's starting to adopt Terraform? What are the sort of things they have to look out for?
So with Terraform, you can create reusable modules, and they can be, like if you create small reusable modules, you can compose them the same way you would with code, for instance. So yeah, basically if you create small reusable modules, you can then share those through some other means. So either in a Git repository, in a local file, or through a module registry. There are then, for instance, I know there are folks who have Terraform modules that exist for creating a service fabric cluster as an example. They have tests for those modules. So they're able to offer pre-built modules internally from that core service team, and then give those to developers who may not know the specifics of how that actually works, which means that you can have well-defined secure modules, I guess, or secure configurations built in these modules that are easily reusable or easily cherry pickable. To
author your HCLs, what sort of tooling, what's sort of your ultimate tool set you would use to write your Terraform configurations?
Sure. So, yeah, I mentioned Terraform has a DSL called HCL. So there's plugins for HCL for a ton of different editors at this point. So VS Code, Atom, the IntelliJ suite, I think there's a Visual Studio plugin. There's just about everywhere at this point. I think it's in Vim and Emacs and whatever else. So you can pick the tooling and work with it. Where Terraform's a command line tool, you can work with it on any shell you want. Yeah, and then there's some extra wrappers. So it's also available within Cloud Shell, which means you can just go to the Azure portal, click the little terminal button, and open it there, which is actually really nice because it means that you don't need any credentials So you can literally just go there, work in Vim or whatever editor you're using, just run Terraform apply and it just does its thing. There's then some additional plugins for VS Code, which sync your local directory to Cloud Shell and do magic behind the scenes.
It's very easy. It's just built in. You don't have to pre-install anything. You open the Cloud Shell and it's ready to use.
Yep.
Very nice. So how do you think Terraform will actually change our industry over the next couple of years? So what's the big things coming out of Terraform?
So we have Terraform. So Terraform's currently at 0.11 dot something, 8 or 9. We have a new version of Terraform coming out soon called Terraform 0.12, which includes some changes to the underlying configuration language. It also kind of sets us up for the future. Terraform has evolved very quickly over the last 3-4 years, however long it's been going now. But yeah, I mean, we have an enterprise product that works with this. We also have some, we're trying to apply policy to your code as well. So for instance, let's say you have a policy requirement that you only deploy in this region, or you're only allowed to deploy between 9 and 5. We have some extensions to Terraform called Sentinel, which is a policy as code framework that allows you to say, hey, you're trying to deploy outside of hours. Like you need a manager's approval or whatever it is you're doing. So there's Terraform is, I think there's two things. The first is to enable enterprises to work better with the existing stuff they've got. The second is Terraform supports providers. So we support 88 HashiCorp supported providers at this point. It's growing all the time. There's 80 community supported providers too, and then you can build your own. The number of providers is expanding rapidly. I think it was like 70 something as a whole when I joined last year, and it's now 160 or so.
That's amazing, yeah.
So it's growing pretty quick.
I can't wait to start using it and kick the tires and see how it goes.
It's quite nice just to call out data sources particularly. So you can reference an existing resource that's managed through the Azure CLI, the Azure Puddle, ARM templates, whatever, and not modify it. So you can create decoupled configurations this way, which is quite nice.
Cool. So a great place to start would be to go to the Terraform website, go to documents.
Yep. Yeah,
and everything you need there.
Yeah. So each of the resources that Terraform supports for the Azure provider, as an example, has an example snippet on how to use it. It then has properties and all the supported values. You've also got the Azure API docs and ARM templates, whatever. The fields generally match. So,
thank you, Tom. That's all the questions I have for you. Has anyone got any questions for Tom about Terraform? Yes.
So just to summarize that question, a new service becomes available in Azure like all the time. What's the rough turnaround time for like a new thing being supported to when it's available in Terraform? So this is kind of a two-part answer. The first is that Terraform supports integration with ARM templates. So everything that an ARM template supports, Terraform supports today. So that is both like stuff in preview, so like private preview, whatever it is that Terraform doesn't support. There's then the actual native Terraform resources, which you were asking about. We're adding stuff all the time based on customer demand. AKS is a good example. We launched as soon as it went GA. So we're basically adopting a policy of once something hits public preview, we're happy to support it in Terraform. Private preview, et cetera, like we can't do for reasons, but like if something's in public preview, it means the APIs generally, like the schema generally won't change. Yeah, it's open source as an SDK. It's basically as soon as the SDK is available and someone requests it, we can look into adding it. So just repeat that. So Terraform being open source, is there any kind of costs associated with it? So Terraform is a two-part thing. There's Terraform open source, which is, as you mentioned, open source. All the Terraform core, all the providers are open source. We then have a separate thing called Terraform Enterprise, which builds on that. If you want to use Terraform open source, it's completely free. You can clone the repo, you can do whatever you want, you can download the binaries. It's there, feel free to use it. Terraform Enterprise is a paid tool. It's like additional things on top of open source. So as I mentioned, the policy is code framework. We have some like workflow management stuff. It's basically stuff that will apply to larger enterprises. Our sales team would be the best people to chat to on that. But as I mentioned, like Terraform open source, the main part is completely free. So you can get started for nothing. So just to repeat that. In an ARM template, you have an incremental and a complete mode within an ARM template, or within an ARM template deployment, sorry. Do you have that in Terraform? So short answer is technically yes, but no. So Terraform supports the ARM template deployment, so it actually supports incremental and complete deployment for that specific resource. Terraform itself is more, it'll do incremental deployments, but it treats the resource as it treats it the same way an ARM template deployment would be complete, if that makes sense. So Terraform, anything defined in code, let's say you have a virtual network and you've defined the subnets in it. There are two ways of doing this. You can either do that within a virtual network, in which case Terraform will manage all those subnets and say, hey, if this subnet, like if I have 3 subnets in code, there's 1 external, Terraform will go and remove that. You can also use a separate subnet resource. What that'll do is it'll just create it and leave the other ones alone. It's kind of up to you to mix and match that how you want. If you have subnets that are created dynamically, for instance, using some of the like the integrations with Kubernetes, then you might want that to just create them ad hoc. If you're in a stricter environment, you might want to say, hey, these are the only 3 subnets that can exist, as an example. It depends. How would I summarize that? So, so there was a question around how you build custom providers and kind of how that works under the hood. With Terraform 0.11, which is the current release, Terraform uses RPC. Yeah, pretty sure it's RPC. It's switching to gRPC in the next version. We officially support, so Terraform itself is built in Go, using the Azure SDK for Go, and all that thing. When it switches to gRPC, there's technically nothing stopping you. We would recommend using Go just because it's there. Otherwise, you'll have to write your own gRPC implementation. But fundamentally, a Terraform provider is a list of data sources, a list of resources, both of which support CRUD operations, or which support CRUD operations. So here's an API to create, read, update, delete this thing. And yeah, that's basically it. Terraform Core deals with the complicated diffing. You basically say, here's the properties from the Terraform configuration, from the configuration file, pass that out, do whatever you're doing, and then read those properties back into Terraform.
Well, thank you, everyone.
Cool.
That's great. Thanks, Tom.
Thanks a lot.